All right. Cool. All right. Welcome, everyone. I hope you're enjoying your TDX so far. I actually just found out that Parker was just giving some type of Q&A, so thank you for coming to my session, or leaving his session. If you're wondering what we're going to be talking about today, we're going to be talking about CSS Grids, in particular the Salesforce Lightning Design System grid system. And hopefully show you how to use it, and by the end of this, master a couple of the concepts that we use. My name is Brandon Frua. I come to you from the User Experience Department. I'm working as a Principal UX Engineer, working specifically on the Salesforce Lightning Design System. So before we get started, I just want to get a show of hands, just like so I can get a feel for everyone. How many of you have heard of the Lightning Design System? Okay, great, perfect. How many of you regularly use it? Okay, it's pretty good. Beautiful slide. I'm sure you've seen this, but we are a publicly traded company, so please make your buying decisions only on products that we have commercially available today. So grids, layout in particular, has come a long way. So I just want to go through some of that history and just kind of take a moment and see where we've come from. So it really started with table solutions was our first kind of attempt at forcing layout into some of our app and web design. So it's kind of a funny story. This Space Jam website is actually publicly available still. If you Google it, you can actually find it. The whole thing is built on tables. It's brilliant. It's beautiful. But tables in particular, you know, they were great for what they were worth, but they came with their fair share of problems. In particular, we were not able to write semantic HTML. Everything was built in the table. Most of the layout was described or defined through the HTML, so we would adjust things like column spans, widths, applying them directly to the table cells to essentially lay out our website of our app. And then there was this concept of cell spacers. I don't know who was developing apps or websites around that time, but I'm sure you know. It wasn't pretty, I'll just leave it at that. But all in all, this left developers very frustrated. But there was one positive thing. It did work in Netscape, so that was pretty cool. So next we moved into this inline-block layout solution. This is a clever way of figuring out our layout problem. One of the biggest jumps was that we were able to start writing semantic HTML. So we were able to describe or change the layout through CSS, and that allowed us to change, you know, our HTML to actually be semantic itself. So that was a huge win. But it did come with its own set of baggage. You had to be very specific about your widths. There was some general white space issues. There was always this finicky, like 1 or 2 pixel white space on the left and right side of your elements. And it had limited flow direction of left to right. But it was a good step in the right direction. And the next, and probably what most of you are familiar with, is float-based layouts. Float-based layouts has become a tried and true method as of late. You know, it still allowed us to write semantic HTML and achieve more complex layouts than we were typically used to. It became popularized by the CSS framework Bootstrap, which as of today, it's one of the most popular open source CSS frameworks. So it had a lot of support and backing. And so many people used it, we'll say that. But again, it had its quirks. Every single row needed to have a clear fix hack. And due to the kind of floaty nature of the implementation, it did come with a higher bar for error. Say you miscalculated a width or used a margin versus padding as your box model, you would find yourself in trouble. I'll just say that. And then finally, today, we come to the Flexbox layout solution. The Flexbox, and I'll get into this a little bit later, but it was our first truly optimized box model for user interface design. And so this is what the SLDS Grid system is built upon. There was one caveat with Flexbox. If you're just using the specification right out of the box, it does have a higher learning curve, but that's where we're here to help. So now that we have some history into the grid system, let's just take a moment to think about why would we use a grid system. So it really boils down to these three basic concepts. So your common layout solution, and this is like really boilerplate stuff. This is, I want some text on the left and I want my button sitting next to it on the right. Next would be component layout. Embracing modularity of that component. How can I lay out this component into certain ways where my grid acts as a skeleton and I'm really just dropping additional components into it. And then lastly, page layout solutions. This would be like your website or your app design. You can think of it as the common like 2 or 3 column page layout design. So now I want to look at why did we, Salesforce, build the SLDS Grid system, and really what is it? So really what it boils down to is my elevator pitch. Is SLDS Grid system is a CSS framework that offers a flexible, mobile-first, device-agnostic layout system. Now I know it's a mouthful right there, but really what that boils down to is you can create awesome layouts on any device, any platform, all with the mobile-first methodologies in mind. And we've actually, because our product is built with enterprise in mind, we built the grid system with enterprise user interfaces in mind. So you, as an implementer, can have more control over such things as like alignment, visual order, flow direction, easily adding gutters, and a whole bunch more. And again, going back to all with enterprise user interfaces in mind. So coming back to Flexbox, this is the reason why the SLDS Grid system is so powerful. Flexbox is the optimized user interface for interface design. And really, when we were thinking about what technology should we use to build this grid system, we wanted to bring that to our customers as the platform for you to build all your layouts. Flexbox, just a little bit of history. The first proposal was introduced back in 2008. It took some time. We went through some iterations of it. Around 2013, we finally had a working draft of the specification. And then in 2015, some of the major browsers, all the way back to like Internet Explorer 11, and then your Chromes and your Firefox, started implementing that latest spec. And so like what we have today, really became a reality, which has been fantastic. Now, before we kind of get into some of the nitty-gritty of the grid system, I just want to cover some grid fundamentals of Flexbox and how we approach layout, solving our layout problems. So I want to talk about the grid container. A grid will always start with a grid container. Without that container, you don't have a grid. You can think of the grid container as like an invisible box around all your columns and rows that we want to establish in our grid. And with a grid container, what comes next? Usually grid items. Grid items once you have your grid container, you can dump your grid items into that grid container. And those are the regions that are used to, if you're dealing with page layouts, dumping your components into, if you're dealing with component layouts, dumping some of your content inside of. So now that we know about grid containers and grid items, we now have all of that power of the SLDS Grid system at our fingertips. And one of those awesome things is automatic sizing. This is probably one of the best features of Flexbox. It really is like the flex in the Flexbox. And what I mean by that is the browser is going to handle a lot of like the complex calculations for you. So I can have as little as 2 items in my grid container, or as many as 12 or 80,000. It doesn't matter. The browser is going to calculate all of those widths dynamically for you. So by default, they're going to spread themselves out evenly. But then that grid item can automatically adjust based on the content that's found inside of that grid item. So say if my region 2 had a bunch of content where my region 1 had a little amount of content. The browser understands that and recalculates itself and adjusts that layout automatically for you. So it's pretty awesome. One of the fundamentals that I want to get into before we really get into it is axes. In particular, I want to talk about the main axis and the cross axis. So the main axis, as you can see here, this is the default. So the main axis is going to flow horizontal, left to right. But I don't want you to think of the main axis as being horizontal, left to right. This is going to just bear with me here. I want you to see the main axis as it's your primary track that you define through the grid system. So, like I said, by default, my flow is left to right on a horizontal main axis. But if I was to adjust my grid to say I want it to start in a column, I'm changing my main axis to be vertical top to bottom. So the cross axis is the perpendicular track to that main axis. So like I mentioned, if my default is left to right horizontal, my cross axis is going to be vertical top to bottom. And the great thing about Flexbox is we can actually change that. So we can describe to the grid container how I want my grid items to lay themselves out. So we can go left to right, which is the default. We can flip it. We can go right to left. We can go top to bottom, and we can flip that too and go bottom to top. I've never ran into a situation where I had to go bottom to top, but it's available. The next great thing about Flexbox and the SLDS Grid system is it's perfect for component layout. Against some popular belief that grids are really only used for page layout, due to the Flexbox and the nature of it being optimized for user interface design, this is a perfect solution to lay out your component in a modular way. So all of these awesome features that I'm talking about here are into our grid system as easily digestible human-readable class names. And what I mean by that is the class names it's really just semantic in nature. So the class names themselves will describe the outcome. So there shouldn't be any second guessing about what to expect. So here you can see I have my grid container, which is SLDS Grid. I want to apply a size or a width to my grid item. So I have SLDS size 1 of 2, and we'll get into that later. SLDS grow none. I'm preventing that grid item from growing. And then SLDS wrap. By default, our grids don't wrap, so this is a mechanism to kind of extend upon what our defaults are. But like it says, it wraps all the elements. Another awesome feature is the grid system is easily extensible. So if you don't like what you see with the defaults, we most likely have some type of modifying class that can be applied to either the grid container or the grid item that can easily extend the behavior of that grid. We have over, I think, 50 extension or modifier classes that can be applied to both the grid container and the grid item to change the behavior of those elements. As you can see on the left hand here, we have an extension on the grid container itself, so grid align spread. It's going to send the elements out to each side of my axis. And on the right side, we have SLDS grow none applied to only one of my grid items. I'm actually telling that grid item to not automatically size and allowing the other one to automatically size. So now that we kind of know what's going on behind the scenes, let's start building some stuff. All right. So first, let's start with some simple stuff. Let's not overwhelm ourselves. All right, so remember that grid container? This is how we're going to initialize it in the HTML. Grid container equals SLDS grid. And it can literally be applied to any HTML element. It can be applied to a div. It can be applied to a span. It can be applied to an unordered list, an ordered list. Doesn't matter. Once we have our grid container initialized, we can start applying grid items inside of that grid container, like we were talking about earlier. And then remember that automatic sizing feature that I've been gloating about? that can easily be applied to the grid item just by applying SLDS call to that element. Again, this really introduces that flexing behavior inside of Flexbox. All right, so now we're feeling pretty good. Let's get into something a little bit more real world. So I want to talk about the media object. The media object is seen as that common layout solution. Typically, it's just an image sitting next to some body of text. Okay. Why I bring this up is what's surprising is most user interfaces are built upon this basic solution right here. So I want everyone to take a look at this chatter feed right here, and I want you to tell me, or count in your head, and then hopefully, if you feel comfortable, say it out loud. How many media objects do you think are on this one screen right here? Come on. 4? 7? I didn't hear anything over here. 2? Oh, man. 7. There's 7 media objects just in this one screen of this chatter feed right here. Now imagine if there was threaded commenting, multiple posts just in this one feed. You could be seeing up to hundreds, even thousands of media objects. So how can we take that concept of a media object and translate it over into code? So here, we want to start with our HTML. You know, at the beginning, I was talking about semantic HTML. I just want to take a moment to talk about some best practices. So the SLDS Grid system is only visually laying out your HTML for human beings. Your HTML should always be written for machines. So we're using that grid system to optimize how our component should be laid out. So getting into it, we want to initialize our grid. And just throwing the grid container class on our element automatically starts making it look like what we saw back in that chatter feed. Now I want to apply just a single purpose utility class to kind of get us a little bit closer to that design. So here I'm applying a utility class of mWriteXSmall to the avatar component. Now M is short for margin. Right is going to describe the direction that I want my spacing to go. So in this case, I want to push my elements to the right. And then XSmall is going to just be the size that I want to apply to that. So mWriteXSmall. So I'm just going to add a little bit of white space between my avatar and the text, and really that's a media object right there. So just that amount of code can be used in thousands of feed posts. Now let's say we get into a situation where this component's being used on mobile. And I'm like, oh man, so my text is actually bleeding off the screen. But I don't understand what's going on because I've used SLDS truncate, sorry, it's a little hard to see here, on the elements that I want to truncate, right? So I don't understand why it's truncating. Again, this leaves developers really frustrated. But that's why we're here. This is why we brought you the framework, because this is a well-tested CSS framework. And we've taken all of these edge cases into consideration when we built it. So Flexbox has its quirks, the higher learning curve as we talked about. So we've taken a lot of these edge case problem areas and applied them to single purpose utility classes. So in this case, Flexbox has a problem truncating text if it's found inside of a grid container. So we've created this class, SLDS has flexi-truncate, that can be applied to any element that's wrapping our truncated text. And that will force truncation to actually work. All right, so now I want to step it up a little bit. That was great, but let's look at something that can be reused. So I want to look at this article card. An article card, it's a pretty common component that you might find out in the wild. It's a nice way to capture the overview of an article. Usually you'll find it displayed amongst other article cards. But it sounds like it's a really good candidate for if I'm receiving some dynamic data to make a reusable component. So here is the design that was provided by our designer. So we have the image. We have a nice heading of text, we have our source, and then we have our timestamp. So let's see how we can build this thing using just the grid system. So here, I'm starting with my HTML again, the most important part. I'm optimizing it for screen readers. So you might notice something really weird about this. So I have my article element, and then I have my content, and then I have my image sitting at the bottom. But if you remember, my image was actually visually at the top. So the reason why I do this is I want my screen reader to actually pick up on my heading 2 first, read that to itself, and then go down the line, read my source, read my timestamp, and then get to the image. Because the image is really only there for presentational purposes. So right now, like, things are looking a little weird, but again, I just wanted to start with that HTML, but we're gonna clean all of this stuff up. So what I wanna do first is I actually wanna change that axis. So I wanna go from left to right, actually from top to bottom, because I noticed in the design that everything was flowing top to bottom. So the way that I do this is after initializing my grid container, I'm gonna extend it and actually change the flow direction by applying SLDS Grid vertical. So things are actually starting to look better, you know. Though my ordering is a little bit out of whack, things are definitely starting to come together. So next what I want to do is I actually want to flip the image. The SLDS Grid system actually allows you to visually reorder elements, but I have to make a point here that you should be very careful with this feature. Subtle tweaks, I think, is just enough. Because like I said, we want to optimize for machine readability. But where you can get into trouble is if you're dealing with multiple tab stops throughout your component, because then your browser gets confused about where it's actually tabbing to. So if you're visually at top, but I'm actually tabbing to something at the bottom, it gets messy and it's not accessible. I don't recommend it. So just small, subtle tweaks. This is a pretty good candidate for visual reordering. So the natural visual order that's provided by the browser is done numerically. So it's actually set, everything is set to a value of 0 for the visual ordering. But with the SLDS Grid, I can manipulate that visual ordering by using our order classes. So here, I want to inherit that default 0, assuming that my image is going to be at the top, and then I'm going to apply an order of 1 to my content to essentially go 0, 1. So I'm going to flip those. And so as you can see here, I'm adding SLDS order 1 to my content region, and that's going to automatically everything. So now I just want to clean up some of the styles a little bit more, kind of get it closer to that original intent by the designer. I noticed that I'm using elements in here that are more long form. I'm using images, I'm using headings, paragraph tags, and I felt this was a good candidate to apply our single purpose class, SLDS text long form, to that component container. And what that's gonna do is it's gonna go look at all the elements inside of my component and start applying the appropriate spacing that the Lightning design system has defined as an optimal amount of line height per heading in margins. So, and then I also wanted to just adjust some of the typographical hierarchy. So I use SLDS text heading small, applied that to my heading 2 to give it a little bit more hierarchy there, and then I adjusted my timestamp by using SLDS text body small. So I made that timestamp just a little bit smaller to provide the nice appropriate amounts of hierarchy. And then lastly, as we saw from the original design, we wanted it to look like a card. And what am I going to do? I'm going to add SLDS card to that article element. So that's going to give me that nice bounding box, that box shadow that I'm expecting from the original design. And then I slapped on a spacing utility of P, short for padding, around. Remember the margin utility that we were talking about? And then my size of median, just to give that appropriate amount of white space that I'm looking for. So I want to take this a little bit further now. So what if we had, and I'm sure that was a good reusable component, but it's not real world. Because usually you're going to get a data set that's probably going to come back with multiple articles. and we want to lay that out in the appropriate manner. So this is going to be the design that we're going to be striving for. So the way that we add these explicit widths is actually through our sizing classes. So our sizing classes are a supplemental utility set that comes along with the grid system that allows you to set explicit widths to either the grid container or your grid items. Here, in our example, we'll be setting some sizing to our grid items themselves. But this is what the sizing class looks like. It's pretty straightforward. So it's SLDS size, and then you append it with the description of what you want it to lay out as. So let's take a little deeper look into what I mean by that. So from the previous example, we saw 1 of 2, right? So this really boils down to just some basic math. You're going to divide the total amount of column spans that you want out of your total amount of columns available. So let's take a look at this example. If we had a 12-column grid, and say I wanted to take up a total amount of 4 columns out of that 12-column grid, all I need to do is literally say that out loud. SLDS size 4 of 12. So this goes back to that easily digestible, human-readable classes that I was talking about. So now going back to our 3-column article river, we want each one of our grid items to take up 1 column out of our 3 available columns. So you kind of see where I'm going here. So first we want to establish our grid container. By default, our grid container actually just flows 100% without wrapping. So going back to that SLDS wrap class, we're going to have to utilize that here because right now, everything is just sending itself off the screen, and that's not ideal. So how do we do this? Is we want to wrap all of our elements by applying SLDS wrap, extending it on our grid container. That's going to force all of my elements to wrap down to another line. Now, the one thing I want to point out here, if y'all can see this, but I did add SLDS call to all of my grid items right now. Now, it's technically not doing anything, but I want you just to pay attention to that because we're going to come back to that later. But I want to get a little bit more explicit about this. So on each one of my grid items, I want to apply that sizing class of 1 of my available 3. So on every single one, I'm going to go ahead and add SLDS size 1 of 3 and make each column 33%. So now things are getting a little bit closer to our original design. And lastly, I just want to apply some gutters around each item to kind of give it that breathing room that I was expecting. And we can easily apply this just by adding SLDS gutters to that grid container class. Now remember those SLDS classes that I was call classes that I was talking about earlier? So this is a critical point right here that if you're using a modifier to extend your SLDS grid or your grid container, we require that you have SLDS call on your grid items because that's our API hook to actually manipulate any of the children found inside of that parent container. Okay? So this is looking really good. Let's step it up again. Let's make this thing responsive. So the way that we're going to do this is actually through our responsive sizing classes. So very similar concepts to what we were looking at earlier, but it's a fantastic way for us to easily get this responsive behavior just right out of the box from our framework. We can have all the sizes that we have available as our default sizing classes available for all different devices. So let's go back and take a look at what the sizing class we were using earlier. So the SLDS size 1 of 3. So what we need to do to make responsive classes work is you just pre-pen a breakpoint name before the size name in your class. So in this case, I just want my 33% 3-column layout on my large device or my desktop. So getting into some of these breakpoint names, I just want to point out, like, you know, we live in this world where new devices are popping up all the time. And so we don't want to describe our breakpoints by the actual device name. So we don't want to say phone, tablet, desktop. We want to describe it through the size of that device size. So in this, we have 3 explicit sizes called small, medium, large. And those essentially translate to phone, tablet, or small laptop, and desktop. So now that we know about the breakpoint names, just one last thing with mobile-first methodologies that I want to talk about is when setting up your HTML, we want to describe or add our classes to our HTML in a manner that we're applying overrides as my viewport size grows, okay? So we're gonna start with mobile first. This is the whole mobile first method concept. And then we're gonna add overrides when we hit tablet. And then once we meet that breakpoint, we're gonna add our override for desktop. And so we just keep adding overrides and modify our layout as we keep going up, okay? So let's go back to that original 3-column HTML that we had before, and let's just modify some things to make this thing responsive. So in this example, typically, we don't have a lot of real estate on our phones, right? So we usually want our components to take up either 100% of the available viewport, maybe 50% in some instances. But here we want 100%. So we're gonna go ahead and apply our sizing class in our HTML as we wanted to see it on mobile. So I want one of my available 1, or 100%. So I'm gonna apply size 1 of 1 to each grid item, okay? So this looks good. But let's move up to a tablet or a small laptop. So this is our first introduction of like really modifying our layout through responsive classes. As you can see here, we changed it where we want to go 2 columns. We want each article card to take up 50%, or one of those available 2 columns on our tablet. So everything's nice and big, makes me want to click on all those things. So we adjust this simply by adding that class after SLDS size 1 of 1, but a responsive size class. So we do SLDS medium, so I'm modifying my medium breakpoint to change to a size of 50%, or 1 of 2. And then why don't we go back to that original design that we had and adjust the layout again to then be optimized for a larger device. So I'm going to add another class, SLDS large, size 1 of 3. And that really gets us back to the original intent that we had, but now it's responsive. It looks great on all different devices. I always love doing this. After I do something responsive, I could just like sit there and just watch it kind of go like boing, boing, boing. But it's fun. It's feeling really good. All right, so some of these examples that I showed, like, really just the tip of the iceberg. I want to encourage everyone in this room, if you haven't used our grid system, for those that are using SLDS today, you know, go jump in, play around with it. There's so many different types of layouts that you can build. But one thing I want to touch on before I send everyone off is I want to talk about what's to come next. So, like I said, we've gone through this history of layout solutions, and we've gotten to this point where now we're thinking down the road into the future. So here is the new specification for CSS Grids, not to be mistaken for SLDS Grid system. CSS Grids are really a new approach to our ongoing layout solution, and it actually might be our final one. So CSS Grids are completely optimized and performant for extremely complex layouts. I don't know how many of you in the room have tried to build some type of dynamic grid system to deal with dashboards. You know, you remove this big, you know, chunk of thing and everything kind of reflows and changes on your page layout, or some type of Pinteresty style mood board. But this is the solution for that. But I have some bad news. We don't have full browser support today. So if you're developing on Internet Explorer 11, this might not be the solution for you. But if you're not, highly encourage you to check it out. But this really is ideal for page layouts. And I personally feel, oh, just one more thing. Look at that amount of code right there for the grid container and the grid regions, which are the grid items. All that built that thing right up top. It's pretty crazy. But I do feel that this, used in combination with the SLDS Grid system or a Flexbox layout solution, it really can solve almost all of your layout woes. So definitely keep an eye on this space. But in the meantime, we just recently revamped our grid documentation on the SLDS website. So you can find it at lightningdesignsystem.com/utility/grid. Everything that I've discussed today, plus so much more, can be found there with examples, all the different extension modifiers that I talked about. So definitely go check that out. And here's a couple of resources I put together for everyone. Give you a second to take a picture of it, but just some code pens kind of showing today's examples, as well as some more advanced responsive implementations. If you want to learn more about the new CSS Grid specification, Grid by Example is a fantastic website. It really shows you the inner workings of how that's working, and they show you working examples of it. And then lastly, check out our grid documentation. So thank you. That's all I have for you today. But I do want to save some time. Yeah, we got plenty of time for some Q&A. I think there's some mics where you can come up here. But thank you. Yeah.
The Lightning layout base components versus this grid system, how much of it is, I'm assuming they're trying to get somewhat level of parity, and then you can add additional modifiers, is that?
Yeah, so the Lightning layout, they took this grid system and essentially componentized it.
Okay.
It has all the bells and whistles that you would expect. Some of their stuff is more out of the box. So you'd have to still probably go read the documentation. You can add classes to extend upon it.
Okay.
But yeah, it's just the componentized solution to our grid system. Okay. Yeah.
So a question, you said that you'll continue to support SLDS grids when you move over to CSS?
Oh, yes, we will not drop support. We will always support this.
Right.
The CSS grid specification, I don't know if we will ever turn that into something that would be a part of the framework or componentized 2020. The reason being is the browser support. Yep. We have so many customers that are still developing on, previous browser solutions that we need to take those in consideration. Yeah. Yeah.
So for media text runoff, we can truncate it, obviously.
Yeah.
And then we can wrap it with flexi truncate.
Yeah.
Anything for wrap?
Anything for wrap?
Yeah.
In terms of text wrapping?
Yeah, so a lot of times when working with like hovers,
yeah,
we've only got such a limited amount of space, and I want to wrap the text instead of truncate it. But
okay.
I can't figure it out for the life of me.
I can tell you an unsupported solution.
Yes, please.
SLDS hyphenate is a utility class that will force wrapping and hyphenation on your text.
Thank you very much.
Unsupported.
Got it. So gutters then.
Yes. Cool. Anything else? Steph, Guy? You guys? I don't have any questions. No? I blow you away.